Welcome to the Deep Dive. Today we're diving into a topic you specifically requested, design patterns in software development. You've sent over some fascinating resources, and we're excited to break them down with you.
It's a great choice. Design patterns are like having a secret decoder ring for elegant software solutions.
Exactly. You know how sometimes you get stuck on a coding problem and it feels like you're reinventing the wheel? Design patterns are like having a blueprint from a master architect. They're not just about copy-pasting code. They're about understanding the core concepts that solve recurring problems in software design.
Think of it like this. You're building a house. You wouldn't design a unique door from scratch every single time, right? You'd use a pre-existing reliable design that's been proven to work. Design patterns offer that same kind of reusability and efficiency for software.
So instead of starting from scratch, each time you hit a common problem, you can pull out a design pattern and adapt it to your specific needs. That's super smart. Our deep dive today is going to explore these patterns and how they can make your code cleaner, more efficient, and easier to maintain. I'm really excited to get into
Me
this.
too. We'll be looking at the three main categories of design patterns: creational, structural, and behavioral, each tackling a different aspect of software design.
Let's kick things off with creational patterns. From the research you sent me, it seems like these are all about bringing objects to life in your code in a clever way.
That's right. Creational patterns give you a toolbox of techniques for creating objects without getting bogged down in complex creation logic every time. It streamlines the process and makes your code more flexible.
Okay, I'm intrigued. Can you give me a specific example of a creational pattern and how it might help me in a real coding situation?
Absolutely. Imagine you're building a game and you need to create different types of enemies: goblins, trolls, dragons, each with their unique attributes and behaviors. Instead of writing separate complex creation logic for each one, you could use the factory method pattern.
Okay, the factory method. Tell me more about how that works.
The factory method pattern lets you define a method in a base class. Think of this like your enemy factory. Subclasses representing your specific enemy types can then override this method to decide exactly what kind of object to create.
So you're basically setting up a system where each enemy type knows how to create itself, and the main code doesn't need to worry about those details.
Precisely. It keeps the object creation logic neatly organized and allows you to easily add new enemy types later without messing with the core code.
That's really clever. I can see how that would prevent my code from becoming a tangled mess as I add more complexity to the game.
It also makes your code more readable and maintainable. Imagine you need to add a new feature that affects all enemy types. With the factory method, you only need to update the base class's factory method, and all your enemies will inherit the change.
That's a huge time saver.
Huh.
Okay, so the factory method is one example of a creational pattern. What other gems are hidden in this category?
Another powerful pattern is the builder. Imagine you're assembling a complex object like a character in your game. This character might have numerous attributes, weapons, armor, skills, and creating it all at once could be overwhelming.
Yeah, I can definitely see that getting out of hand quickly.
The builder pattern addresses this by constructing the complex object step by step. You have a separate builder class that handles the construction process, adding each component in a specific order.
So it's like having a dedicated blacksmith carefully crafting each piece of armor and then assembling them onto the character.
Exactly. And the beauty of this pattern is that you can create different variations of the same object by simply using different builder classes. For instance, you could have a warrior builder that equips the character with heavy armor and weapons, and a mage builder that focuses on magical items and abilities.
That's a super flexible approach. It's like having a character customization system built right into your code.
And finally, there's the singleton pattern. This one ensures that a class has only one instance, providing a single global point of access.
Okay, the singleton, this one piqued my interest earlier. Why would you only want one instance of something in your code?
Think of it like a configuration file or a database connection. You wouldn't want multiple parts of your application trying to create their own separate connections to the same database. That would lead to conflicts and chaos.
Ah, so the singleton pattern helps you avoid those kinds of resource clashes.
Exactly. It guarantees that only one instance exists and everyone accesses the same shared resource. You might also use this when managing things like logging systems or thread pools, where having multiple instances could cause problems.
Wow. So we've already uncovered three powerful creational patterns: the factory method, the builder, and the singleton. You've given me a lot to think about in terms of how I can apply these to my own projects.
And we've only just scratched the surface. Next, we'll move on to structural patterns, which focus on organizing objects and classes into larger, well-structured systems.
That sounds intriguing. It's like moving from designing individual components to figuring out how they all fit together in the grand scheme of your software architecture.
Exactly. But before we delve into that, take a moment to think about your own coding experiences. Have you ever encountered situations where you wished you had a more elegant way to create objects?
All the time, especially when things start getting complex. I can already see how these creational patterns could be game changers for me. Welcome back to the deep dive. We're continuing our exploration of design patterns and how they can revolutionize the way you approach software development.
In the first part, we focused on creational patterns, those ingenious blueprints for bringing objects to life in your code.
And you gave us some really great examples like the factor method, the builder, and the singleton, which I'm already starting to see popping up everywhere in my code. But now I'm curious about how we move beyond creating individual objects. How do we start organizing them into larger, more complex systems?
That's where structural patterns come in. Imagine you're building a bridge. You wouldn't just throw a bunch of beams and cables together and hope for the best right. You'd need a carefully designed structure to ensure stability and functionality.
So structural patterns are like the blueprints for that bridge. They help us arrange our objects and classes in a way that makes sense, is easy to maintain, and can even adapt to future changes.
Precisely. And just like with a bridge, there are different structural designs that work better for certain situations. Let's take a look at a couple of those patterns and see how they can help you create more robust and scalable software.
Okay, I'm ready to build some software bridges. What's the first pattern we're going to explore?
One that you'll likely encounter quite often is the adapter pattern. Have you ever tried to connect two components that just weren't compatible? Maybe you had a legacy system using an outdated API, but your new application needed a different format to communicate.
Yeah, I've definitely run into those compatibility headaches before. It's like trying to fit a square peg into a round hole.
That's a great analogy. And the adapter pattern is like creating a special converter that allows those mismatched components to work together seamlessly.
So it bridges the gap between two incompatible interfaces. That sounds incredibly useful, especially when you're dealing with integrating different systems or libraries.
It is. Think of it as a universal translator for your code. It allows objects with different interfaces to communicate and collaborate without requiring major changes to their existing structure.
I'm already starting to see how valuable this pattern could be in my own projects. But I'm also curious about how we can extend the functionality of our objects without making our code more complex. Is there a design pattern for that?
There is, and it's called the decorator pattern. Imagine you have a basic coffee object in your code. It has the core functionality of brewing coffee, but now you want to add options like adding milk sugar, or even fancy flavors like caramel or hazelnut.
Okay, so I could just add those options directly into the coffee object's code, right? But I have a feeling that's not the most elegant approach.
You're right, adding all those options directly into the coffee object would make it bloated and difficult to maintain. What's worse, it wouldn't be very flexible. Every time you wanted a new flavor, you'd have to modify the core coffee class.
That sounds like a recipe for a messy code base.
Exactly. The decorator pattern comes to the rescue by allowing you to add new features or behaviors to an object without altering its original structure. It's like adding those coffee toppings dynamically without messing with the core brewing process.
So instead of modifying the coffee class directly, I would create separate decorator classes for each topping. Those decorators would wrap around the basic coffee object and add their specific functionality.
Precisely. You'd have a milk decorator that adds milk, a sugar decorator that adds sugar, and so on. And the beauty of this is that you can combine these decorators in any way you like. You could have a coffee with milk and sugar or one with caramel and hazelnut. The possibilities are endless.
And it keeps the core coffee object clean and focused on its primary responsibility, brewing coffee. That's a fantastic way to add flexibility and avoid code bloat.
The decorator pattern is incredibly versatile. You could use it to add logging functionality to a class, implement security checks, or even create graphical user interface elements. It's all about dynamically enhancing objects without modifying their core structure.
Okay, so we've covered two key structural patterns. The adapter, which bridges the gap between incompatible interfaces, and the decorator, which lets us dynamically add functionality to our objects. I'm starting to see a recurring theme here. These patterns are all about making our code more adaptable and maintainable.
You're absolutely right. And there are many more structural patterns out there, each addressing specific challenges in organizing and structuring your software. We'll delve into another crucial category of patterns, behavioral patterns, in the next part of our deep dive.
Behavioral patterns, those sound even more intriguing.
Uh,
I'm guessing they're about how our objects interact and behave within our software ecosystem.
you guessed right. Behavioral patterns deal with communication between objects, algorithms, and the assignment of responsibilities. They're like the social etiquette of your code, ensuring everything runs smoothly and efficiently.
I can't wait to learn more about that. But for now, let's take a moment to reflect on what we've learned about structural patterns. Think about the projects you're working on or the systems you interact with daily. Can you spot any potential applications for the adapter or decorator patterns?
Remember, design patterns are about recognizing recurring problems and applying proven solutions. The more you familiarize yourself with these patterns, the more naturally you'll start to see them emerge in your own work and in the world around you.
Welcome back to the deep dive. We've journeyed through the rounds of creational and structural design patterns. And now it's time to explore the fascinating world of behavioral patterns.
You can think of behavioral patterns as the choreography of your code. They dictate how objects interact, communicate, and distribute responsibilities. It's all about ensuring smooth collaboration and efficient execution of tasks.
So far, we've seen how design patterns help us create objects effectively and organize them into larger structures. But how do these patterns influence the actual behavior and interactions within our software?
Let's dive into a couple of examples to see how behavioral patterns bring your code to life. Imagine you have a system with multiple objects that need to handle a particular request. For example, think of an online store where an order needs to go through various stages: order processing, payment verification, shipping, and finally, confirmation.
I could see how that could get pretty complicated. You'd have all these different objects responsible for specific tasks, and the flow of information between them would need to be carefully managed.
Exactly. And that's where the chain of responsibility pattern comes into play. Imagine these objects forming a chain, and the request is passed along this chain until one of the objects is able to handle it.
So it's like a game of hot potato, but for code. The request keeps getting passed along until it finds the right object that can take care of it.
That's a great way to visualize it. Each object in the chain has a chance to examine the request and decide whether it's equipped to handle it. If it can't, it passes it along to the next object in the chain. This continues until the request reaches the appropriate handler.
That sounds like a very flexible and efficient way to manage complex workflows. What happens if none of the objects in the chain can handle the request?
That's an important consideration. You can design the chain to have a default handler at the end that catches any requests that fall through the cracks. This ensures that the request is never lost and that there's always a mechanism to handle it, even if it's an unexpected or unusual request.
That's a clever way to build in robustness and prevent errors. Okay, so the chain of responsibility helps us manage complex workflows by passing requests along a chain of potential handlers. What other behavioral marvels await us?
Let's shift gears and look at the observer pattern. This pattern is all about keeping objects informed about changes or events happening within the system. Think of it like subscribing to notifications or following someone on social media. When something interesting happens, you get notified.
Okay, so instead of objects constantly checking for updates or changes, they can simply subscribe to be notified when those changes occur. That sounds like it could significantly reduce unnecessary processing and make the system more responsive.
Exactly. You have a subject object that maintains a list of its dependents called observers. When the subject's state changes, it automatically notifies all its observers, providing them with the relevant information about the change.
So it's like having a news broadcast system within your code. The subject is the news anchor, and the observers are the viewers tuning in to receive updates.
That's a great analogy. This pattern is incredibly useful when you need to maintain consistency between different parts of your application or when you want to decouple objects so they don't have to be directly aware of each other's internal workings.
I'm starting to realize that design patterns are not just about technical solutions. They're also about creating elegant and efficient communication pathways within our code.
Absolutely. They help us build software that is not only functional, but also adaptable, maintainable, and scalable. By understanding these patterns, you gain a deeper understanding of the underlying principles of good software design.
We've explored three main categories of design patterns: creational, structural, and behavioral. And you've given us some fantastic examples of how these patterns can be applied in real-world scenarios. But I'm curious, how does one go about developing this design pattern sense? Is it just a matter of memorizing a bunch of diagrams and code snippets?
Not at all. It's more about understanding the underlying principles and the problems they solve. The resources you shared with us are a great starting point. As you become more familiar with different patterns, you'll start to recognize those recurring challenges in your own coding.
So it's about developing an intuition for recognizing when a design pattern might be a good fit for a particular problem.
Precisely. And remember, you don't have to do this alone. There's a vibrant community of developers who are passionate about design patterns, engage in online forums, read articles, participate in discussions, and share your own experiences. The more you immerse yourself in this world, the more naturally you'll start to think in terms of design patterns.
This deep dive has been an incredible journey. We've uncovered the secrets of design patterns, explored their diverse applications, and learned how they can elevate our coding to a whole new level. Thanks for guiding us through this fascinating landscape of software design. I'm sure our listeners are eager to start applying these patterns in their own projects.
It's been my pleasure. Remember, the world of software development is constantly evolving, and so are design patterns. So keep exploring, keep experimenting, and most importantly, keep sharing your knowledge with the community. Happy coding, everyone.